Okay, so we were focused on geochronology of SPA and then potentially other craters that were on top of it, but really we focused a lot on SPA. And to kind of give you the summary at the beginning, this was hard. I hope that the other groups also really struggled to kind of get back into this, the assessment of these are the exact things that we need. But really all of us are kind of looking at maximizing the likelihood of addressing a single scientific goal or really multiple scientific goals at a location. And so we're really just looking at the geochronology for that. And from that, we came up with 3 different metrics. And although I say 3 different metrics, they're really all getting back to one thing. And I think one big collective. But for the chronology, we need to make sure that we have good geologic context to be able to constrain that chronology. And also we have to be able to collect the right samples that we need for chronology and be able to actually physically collect them. So what we came up with is that between these 3 metrics, that really it boils down to the need for a multi-layered integrated map in terms of how are we going to choose the landing region and the landing site. We need to be able to have more detailed stratigraphic assessment of those regions. And so these are just a few examples of some of those potential layers that would be in there. Ages, the elements, maturity, boulders, and topography. So for example, if we're trying to get towards the massifs as an area to try to find some of that SPA material. And from this, we're also advocating for some sort of funding mechanism to be able to have a consortium mapping effort. It's a lot. There's a lot of different data sets. We need them to be integrated and be able to talk to each other into a single unit. And so we're advocating for that here in our first slide. Being bold. Went the wrong way. Let's see. Okay, we had 2 lightning talks, and without going into them in too much detail, really we had one that really talked about the ability of humans to be able to do complex tasks and not to shy away from complex tasks. And then our second one talked about we need to have a good understanding of the stratigraphy, and we also need to be able to actually get the materials that we need to really get to the chronology. We had 12 participants, so we had a few people that popped in and out, so thank you for everybody that provided some information. So we've got 3 metrics here that I'm going to go through. Our first is the chronology anchor potential, so what is our ability to actually anchor that chronology. And our science goal is maximizing the ability to date the material that we intend. So if we are intending to date SPA material, we need to maximize our ability to actually get SPA material. So we talked a lot about how complex the terrain is and how do we actually get materials that are likely going to be giving us that information about SPA. So we would like to be able to maybe go to the massifs, potentially even a high topography area or high topography landing site. Maybe that's a separate metric. We kind of got to that towards the end in terms of areas that do not have that fine-grained regolith or have less of that fine-grained regolith, because we don't necessarily want the material that is so crushed up and fine, because we're probably not going to get the material that we need to actually be able to do the chronology. And so how do we figure out the material that we really need? We want to be able to get impact melt. We want to be able to get regolith breccias from various places, because that's going to help us get to potentially get to an age, just falling out from statistics. The second one that we have here is the stratigraphic context quality. We need to understand when we are selecting an area to go to, how does this unit relate to the others stratigraphically? So we need to be able to target specific materials intended for geochronology in a pretty complex terrain. So we need to make it easy to interpret. And we need to be able to understand the relationship between all those different lithologies to be able to better get that geochronology. And this is really, again, getting back into those multi-layered maps. So we need, for example, really good NAC images to be able to find boulders, to be able to look at those stratigraphic relationships between units. So having reasonable incidence angles as an example in terms of getting back to the particular assessment. If there are places in the South Polar region where there are descent images, maybe we can also use those to get us a little bit more information in terms of the relationship between the different materials. Some disagreement about craters. Craters make things complex because they mix the materials, but at the same time, if you look inside the crater, maybe we can see the layers actually see a stratigraphic column. We can see maybe how thick some of the different units are, so we can again get some of that context before we go to a site, or also in terms of selecting a particular site. We also would like to try to get to materials that are fairly homogeneous. That's really hard to do. So what are the small areas that are maybe a little bit more homogeneous, where we're going to have a better idea of knowing, okay, we think we know what this material is. We think we know how it's related to these others. It's older than this, it's younger than this. We have cross-cutting relationships, et cetera, et cetera. So again, getting back to those remotely sensed data sets. And one might be tempted after this one to say, oh, well, you need to go to somewhere as simple as possible. But really that kind of feeds into our last one, is that we're going to have humans. And humans are capable of interpreting complex things. And so we shouldn't necessarily shy away from areas that are complex. And obviously we're going to the South Polar region. It's fairly complex anyways, right? But to be able to maximize the uniqueness of the Artemis 4 contribution to SPA science, we need to be able to really lean on the humans and understand that they can accomplish really great things that maybe robotic explorers would not be able to. So there needs to be some sort of intersection really between identifying units that are homogeneous and kind of clean and easy to see with, hey, we can actually go to places that are a little bit more complex. And together, these will allow us to be able to collect the variety of samples that we really need to from across a landing region, from across a landing site, to get back towards, okay, what are the different lithologies here? Which one is SPA? And so again, it gets back to that complexity layer map and all those different layers that we have. So I'm going to go back to our discussion summary because those were our three metrics. And I wanted to again highlight that these three metrics, we have as separate three metrics because that's how we discussed them. But in reality, they all come back down to the same thing, is that we need a multi-layered integrated map that's going to be able to be talking to each other. I know sometimes those layers can be a little bit difficult, but we need the ability to have this mapping effort happen. Otherwise, it's going to be a little bit challenging. Anybody from the geochronology group want to add anything to that?
Oh, hey, I can unmute. All right, fantastic.
Hi, Brad.
So my question, hey, that was very interesting. Lots of questions, but I'll just ask one. I'm thinking about geologic context and stratigraphy. Mm-hmm. We all talk about stratigraphy, and thinking about the moon, it's usually things like overlapping crater ejecta. At what scale are you thinking about stratigraphy, and how does one recognize it in the South Circumpolar region, where we have a lot of really heavily, really old terrain, but heavily cratered? Mm-hmm.
Yeah, well, it's hard, right? Yeah. So one of the things we talked about, Brad, and I'll get started, and then I'll let somebody who's actually a remote sensor or mapper take over. But we talked about the need for multiple resolution is not the right word. My brain is failing me. No resolution. How far down do you want to go, right? So we kind of need that big, broad, big picture, and then we get more detailed as we go. But I'm going to let one of the remote sensors take over. Or Jeremy, are you on? Maybe you can take over that one. Jeremy on? Oh, Jeremy raised his hand, Ricky. I think Jeremy probably is better able to explain this than I am.
Voice, Ricky.
Yeah, I was just having a little trouble with my mouse.
That's okay. Jeremy, go ahead.
Yeah, so I think that the mapping is valuable at whatever scale you can accomplish. And
Scale, that's the word.
Yeah, I knew it. I couldn't say, I was yelling at my computer, but it wasn't helping you at all. Yeah.
It's not even that hard of a word.
Even the recognition that, for example, you could make out in an image that there was more than one definable unit in an outcrop would be valuable, even if you didn't know ahead of time exactly which one it was, or that you had some concerns that you were, that you had some uncertainty, right? I think one thing that we recognize is that this is probably the hardest part of all of this, because I think there's probably some, geochemistry people who can be like, here's a thorium map and here's a potassium map, and they're done. And the geologic mappers are probably looking at this going, you're asking for the impossible. But again, I think the value of whatever kind of highly resolved geologic information that you can add to all these other layers multiplies their benefits tremendously. So whatever you can do to take the zoomed out geologic map and in those candidate zones to improve that resolution, that's all we're asking for.
Yeah, so it's some combination of perhaps topography, surface texture, albedo, existence of boulders or non-existence, whatever things you can get at to say this little bit of terrain is different from another.
That, and also the choice of layers might be different for different specific science questions, right? The geochronologists are really concerned about getting rocklets and not dust, as you well know. And so that might be a really important feature for one application. But this as a sort of philosophy, that we have all these different data sets and we should be able to integrate them more easily to make these kinds of discussions or decisions and recommendations. And then also seeing that there's something missing, and that's maybe that high resolution mapping, even if it's hard.
Mm-hmm.
Awesome. Well, thank you so much for leading this group and having this discussion. We really appreciate it.